Guys, this is Arun and I'm back with another video on development of lateral surface. Now here we will be using the paper, pencil, scale and all the drawing instruments and actually see how we need to draw the development of lateral surface for a hexagonal pyramid, which is cut by a cutting plane or a section plane. So the statement is before you. As you can see, you have a hexagonal pyramid which is 25 mm sides of base and axis is 65 mm long. It is resting on its base on HP with one of its edges of the base parallel to VP. It is cut by a section plane at a distance of 8 mm from the axis towards the right side. You need to develop the lateral surface of the left part of the pyramid. So now we need to first draw the top and front view of this particular hexagonal pyramid resting on HP. So what you need to understand here is it is having a base edge side of 25 mm and height 65, and it is resting on HP on one of its edges of the base parallel to VP. So as you can see here in the top view, you need to have at least one edge of the hexagon parallel to VP. So this is the initial position. So you have the edges EF and BC, two edges parallel to VP. So this is your initial position. So we'll start with this and then proceed with the front view. So I'll be drawing the front and top view first. So starting with the XY line, I'll draw the top view. So you have a hexagon of 25 mm sides. So this is what I'm going to draw here, 25, yeah. So 25 mm, and then the next edge could be at 120 degrees. So around here at 120, and around here .25 mm. 25 mm. Similarly 120 degrees at this end, so 120 here. So 120 here. Then 25 mm here. Yeah. And finally join and complete the hexagon. So this is the top view. Okay. So we'll name the corners of the hexagon. So you have A, B, C, D, E and F, and we'll join the corners, the opposite corners to each other, so that we get the apex of the pyramid. So this point is apex, so O, and apex, the line joining the apex O to the center of the base O1 is the axis line. So O into bracket O1 is the axis line. So this is the top view of the pyramid. Now I'll project and try to get the front view. So I'll be drawing vertical projection lines. 1, 2, 1 for A, second B and F, this projection line, for C and D, this projection line, for D, this projection line. So 4, and for the axis O1, another projection line. This I am going to extend above XY line by a height equal to 65 mm. As you can see here, this is the projection line for the axis, and I am going to extend this above XY line by a height so this is the axis line. The top is O dash, bottom is O1 dash, center of the base. Base edge 25, the height of the axis 65, now I'll join the base line and I'll mark the corners of the base, starting with A dash, then this point is B dash, F dash, this is C dash, E dash, and D dash. I'll join the corners of the base to the apex and complete the front view. So if you observe, what you find is in the front view you are seeing three rectangular faces, three triangular faces, and they are OAB, OBC, OCD. Three triangular faces are seen in the front view, whereas the other three triangular faces ODE, OEF and OFA are behind and they will not be seen. So this is the top and front view of the hexagonal pyramid. Now we need to introduce the cutting plane. So if you see the location of the cutting plane is 8 mm away from the axis. So this is the axis, so it is 8 mm away from the axis towards the right side. So it's a vertical cutting plane. So I'm going to draw the cutting plane 8 mm away. So 8 means somewhere here. Yes, I'll mark the point and I'll draw the cutting plane. So this is the cutting plane, which is 8 mm to the right of the axis. So now this cutting plane divides the pyramid into two halves. One is this portion on the left side and this portion on the right side. Now you need to develop the lateral surface for the left portion, that is from the section plane, the left side, the left portion of the pyramid has to be developed. Okay, so since the left portion has to be developed, so we'll be darkening the left portion, all the physical edges of the left portion like this, just to highlight which portion is being developed. Yeah. So as you can see, this is the left portion and this has to be highlighted. Now once you are done with highlighting, now we have to mark the intersection points. So we need to see which cutting planes these which physical edges this section plane intersects. So as you can observe, it is not intersecting OA, that is O dash A dash, nor it is intersecting OB, that is O dash B dash. OC, yes, it is intersecting. So at this point, somewhere at this point, O dash C dash, so you can mark that. And but before OC, if you observe, it is intersecting the edge of the base. Now which base edge, that you will come to know here. I think you can see it here, it is intersecting at this point here. But in order to come to know which exactly is that base edge, you need to project that onto the top view. So when you project, what you find here is, this is the base edge, that is BC. BC is the base edge and this is the intersection point. Okay, so since this is the first point, you can name it as 1. This is 1. This is the second intersection point, you can name it as 2. Then you have OD. Yes, it is, the section plane is intersecting OD, that is O dash D dash, here at this point. So this point is 3. Then is it intersecting OE? Yes, at the exact point where there is intersection point 2. So at this point we'll have another intersection point 4, but I'll put 4 in bracket because 4 is behind 2, that is OE is behind OC, so OE will not be seen, so 4 won't be seen, so I put it in bracket. So it intersects OE at the intersection point 4. And finally it is also going to intersect another base edge that is somewhere here. That is, if you project it down, you will find that it is EF. So EF, and at this point, so this is 5. So here you can put 1. I'll just rub all these things. It is making the visibility bad. So I'll rub all this just to improve the visibility. So this is C dash into bracket E dash, this is O1 dash, and this is 1 dash into bracket 5 dash, this point here. Okay, so you have 5 intersection point, 1 with BC, 2 with OC, 3 with OD, 4 with OE, and 5 with EF. So 3 are intersections with the generators or the slant edges, and 2 are intersection with the base edges BC and EF. So there are 5 intersection points. So the next thing is to find out the true length of these intersection point with respect to the apex, and then transfer it onto the development of the full pyramid. Now if you observe, among the 5 intersection point, only the intersection point 3 is on the true length of the slant edge. So if you observe in the front view, only OA and OD, these are the only 2 slant edges which are in true length in the front view. None of the other 4 slant edges are in true length. So all your intersection points should be on one of these 2 slant edges, either OA or OD. Now you find that only 3 is on OD. So this is the only slant edge which is in true length, and 3 is the only intersection point which is on the slant edge. So our job next is to project these intersection points, that is 2 and 4, onto the true length of the slant edge. So we'll do that. We'll project 2 and 4 onto the true length of the slant edge. So this is a new intersection point, 2, 4. Now we need to measure these lengths. And then use it for the development of lateral surface. And if you observe, 1 and 5, these are already on the true length of EF and BC. If you observe, BC is 25 mm, so is EF. Now 5 and 1 are on the true length of BC and EF, so there is no need to project them anywhere. You just need to find out the length of E to 5 or C to 1 in order to locate the intersection points 1 and 5. Now next is we'll draw the development of the lateral surface. So before that, we need to measure the length, the true length of this generator. So let us of this slant edge. So let us find that out. So if you observe, the true length of OD is almost, you can see, 70 mm. So mark it, locate it properly, 70 mm. So this is going to be helpful for me to make the development of lateral surface for the entire pyramid. So you know the process to do that. So if you cut open a pyramid at, say, OA, if you cut it open and if you spread it, you'll get 6 triangles. So you need to draw the 6 triangles first. So I'll show you how that is done. So first measure this. the length of the true length of the, yeah. So with O as center, this is the center O, and radius 70 mm. I am going to draw an arc. An arc. So this is an arc whose radius is 70 mm. So this point is O. Okay. Now I'm going to start with one of the endpoints. So you can say that this is OA. So if I join O and A, this length is 70, and this is the first slant edge. Then the next slant edge, that is OB, OC, OD, all are found at 25 mm distances. So what I'll do is I'll measure 25 mm. So 25 mm, and then I'll go on marking remaining points 25 mm away. So I'll mark like this: 25, 25, 25, 25, 25, and I'll name this. So this is B, C, D, E, F, and since you started with OA, you are going to end with OA. So now these are your 6 slant edges. So join them with thin lines. These are all the slant edges that I have located 25 mm away from each other. So what you see here is the full development. This is the full development of the pyramid, the lateral surface of the pyramid, but it is not complete because you have to join A to B. This is a straight edge B to C. All these are straight edges, the base edges, C to D, D to E, E to F, and F to A. So you have these 6 triangular faces representing the development of lateral surface for the complete hexagonal pyramid. Now our job is to locate these 5 intersection points 1 to 5 on this full development. So if you want to locate the first intersection point, that is 1 is between B and C, so between B and C, so you can find out the distance. It will be very small. I think it's around 5 mm or 6 mm from C. So between B and C, 6 mm. So I'll just draw it here, 6 mm. So somewhere here. This is point number 1. Next I'll locate the second point. Point number 2 I can locate with the help of the rounder. So from O, yeah, so from O, it is with OC, so this is the point. So this is 2. Now if you see 4 is also at the same distance, but 4 is the intersection with OE, so I'm going to locate 4 also using the same distance as O to 2, but 4 I'm going to locate on OE, so I'm going to locate here. So this point is intersection point number 4. Now I'm left with 3 and 5, so I'll locate 3 first. So from O to 3, yeah, and 3 is intersection with OD. So it is at this point, so this is 3. And last but not the least, 5. Intersection point 5 is between E and F, so it will be between E and F. So I need to locate the distance. It will be the same 6 mm as you can see from E. So from E towards F, 6 mm. So somewhere here. This point is 5. So you have all the 5 intersection points. Now you can join them by straight lines. So 1, 2, 2. Make them dark, as you have to highlight which portion you want to retain. 2 to 3, 3 to 4, 4 to 5. Okay, now this is these are the intersection points. Now you want to develop the left portion, so that means this upper portion here. So all these lines you need to darken, starting from OA, this OA here, then OB. All the physical edges need to be darkened. Similarly OF, and this A to B, A to F, then this E to F, then B to 1, and don't forget to darken these physical edges also. 2 to O, as it is part of OC, and O to 3 as it is part of OD, and O to 4 as it is part of OE. So this completes the development of the left portion of the pyramid. So this area that you see is the development of the lateral surface of the left portion of the hexagonal pyramid.
So here I have the hexagonal pyramid, and you can see it is cut by a section plane 8 mm away from the axis, and you can see that it is cutting the edges of the base, this edge and this edge, and also the slant edges. So I'll show you how it looks like when you cut and when you take out this right portion of the pyramid and when you retain only the left portion of the pyramid. So I'll hide this and I'll show you the split portion. Yeah, yes. So when you take out the right portion and you want to develop only the left portion, this is what is left of the left portion of the pyramid. So as you can see, you have your intersection points here: 1, 2, 3, 4 and 5. Okay, so this is what it looks like, and to make my point clear, yeah, so what you find here is AB, BC, CD, DE, EF and FA. These are the edges of the base, and you have OA, OB, OC, OD, OE and OF, the slant edges of the pyramid. So this is a section plane, and you can see these yellow dots. These indicate the intersection point. So if you see, then 1 here, 1 is the intersection with the base edge BC. 2 is the intersection with the slant edge OC. 3 is the intersection with the slant edge OD. 4 is the intersection with the slant edge OE. And last 5 is the intersection with the base edge EF. So this section plane cuts the pyramid and divides it into two parts, the left and the right portion. So you are asked to develop the left portion. So if you take out the right portion, this is how the pyramid is going to look like. You can see the intersection points 1, 2, 3, 4 and 5. So this was a problem where you had a hexagonal pyramid cut by a section plane which is perpendicular to VP and a distance of 8 mm from the axis. So please practice this problem as it is one of the very important problems, and I'll see you again with another video on development of lateral surface.